OK, so now that we've seen our first buffer overflow and we saw how it works with the x86 instructions, we're now going to start looking at other pieces of C code that might seem safe at first, but they're actually going to turn out to be dangerous because of the same fundamental flaw, which is that in C, there are no bounds checking. There is no bounds checking. So what that means is C doesn't know where things begin and end. We can write past the end of arrays, can do all sorts of dangerous things. So that's kind of our next topic. So here's a piece of code. And at first, it might seem like, this seems OK, because I'm no longer overwriting something on the stack. So maybe I can't overwrite the RIP anymore. And specifically, in this case, name is an address, and it points at some memory in the heap. Remember, when you call malloc, you get some data in the heap. And so this time, at first it seems, well, maybe this is OK. I'm no longer overwriting things on the stack. So maybe I can no longer target the RIP and do the same stack smashing attack from earlier. So you might say, well, maybe this is OK. But it turns out there's still some danger here, because again, I can write past the end of the 20-character array. So for example, maybe I have lots of different things on the heap. I have a name, I have an authenticated variable, I have the airline instructions that we saw from last time. So there could be all sorts of sensitive things on the heap. And if you call getS on some piece of data in the heap, the attacker could supply more than 20 bytes. And if the attacker supplies more than 20 bytes, they're going to overwrite past the end of name and start writing to other things that might be sensitive. For example, I don't know, the instructions character array that tells you the special instructions for the plane, or the authenticated variable that checks if the user is an administrator. All sorts of sensitive things could also be on the heap. So we also have to watch out for overflows, not just on the stack, but also on the heap. So that's what this slide says. So here's an example of how you might try to protect against these attacks. And we'll do a whole set of videos later on protecting against memory safety attacks. But turns out getS is a dangerous function. It lets the user write as much as they want. And to defend against these attacks, you have to use other C library functions. For example, there's one called fgetS. And this one lets you specify a limit and say, actually, the user can only write 20 bytes. And if they write more than 20 bytes, we will not accept any further input. So this is now a safer piece of code because the attacker can't write more than 20 bytes. So you have to do something like this to protect against memory safety vulnerabilities. And we'll go into this in more detail, but just to give you a hint, this is kind of the way that you'll stop memory safety attacks. So as another example, you can even be more secure and say, actually, this is a little dangerous because if I change this to 15, and I don't forget to change this to 15, or I do forget to change this to 15, well, then this would say 15, this would say 20. They would no longer be synced up, and that could be a problem. So maybe you want to be even more careful and use something like size of name. And this is going to evaluate to 20. So this way, I just have a single source of truth. And if I change the 20 to a 15, this will also naturally change to 15. So there's different ways you can approach this. But basically, the punchline is something like getS is not safe. And you have to go looking for the safe alternative. And it turns out there's lots of different safe alternatives out there that you can use. So getS is dangerous. Please use fgetS instead. Strcpy is dangerous. Please use strncopy instead. Strlen is dangerous. Please use strnlen instead. And there's all these different ones that you have to keep track of. And by the way, to give you a preview, this is why C is such a difficult language to work in. You have to remember all these specific functions and remember, OK, this is the dangerous version and this is the safe version. And it can be really tricky. And if you make even a single mistake, oops, suddenly your code is all vulnerable. So you have to be really careful. You have to look up functions before you use them. And if you want to look them up, there's something called man pages, if you're ever curious. They give you the documentation for how these functions work.